Alright, graph a sine function number 13. So we're asked to fill in these values too. We're asked for the amplitude, the period, and the phase shift. The amplitude, of course, is the absolute value of this a value here. Remember, we're working with this, that our function is sine, is y equals a sine of omega x minus alpha, possibly with a k value out there, but we don't need it right now. So amplitude is the absolute value of this, so that's just 3. We have a formula for finding the period, and the period is 2 pi over absolute omega, and therefore we have 2 pi over negative absolute value of negative 2, so the period is just pi, isn't it? So the period is just pi. And the phase shift, PS phase shift, is equal to opposite omega over, opposite alpha over omega. So what we have here is opposite pi halves over negative 2, right? Over negative 2. Remember, that's negative 2 over 1. Negative times a negative is a positive, so equals positive pi fourths. So our phase shift is pi fourths. Okay? Let's go back and look at this. What I'm looking for now, and not everybody does this, but I find that it's really a very simple way to do it, is I want to find an interval that contains exactly one cycle of this curve. So what I do is I take this intersection right here, take this middle section right here, and I place this inside the normal domain of sine. So it would look like this. It would look like negative 2x plus pi halves is less than or equal to 2 pi, which is greater than or equal to 0. You can go ahead and work that out if you like. This will really be helpful for you. If you have questions about it, then ask me in class or ask me through a comment. But let's go ahead and graph this function out. It will look like this, won't it? It'll look like this. I know this is a sine function, but look, it looks like this thing is reflected, but it's reflected here and here. So it actually is going to look like the normal sine curve. You can check it on your calculator. So I'm going to draw this thing that looks like this. I am perfectly aware that this curve is periodic and it goes on and on and on. But all I'm really interested in right this second, for my purposes, is the part that I have that's solid right now. So what I'm going to do is this. I know that the phase shift is pi fourths. So I have this value. The curve is pushed over by pi fourths, so this is the point pi fourths 0, isn't it? And my question is, what's this point right here? And the way you would get that is you would take phase shift plus period. So if you take the phase shift plus the period, you would have pi fourths plus pi, and pi is of course 4 pi fourths, and get 5 pi fourths. So here 5 pi fourths comma 0. Alright? And then of course I do want this midpoint right here. So to find this midpoint right here, what would you use to find that? Well, of course you'd use midpoint theorem. Midpoint theorem says take x sub 1 plus x sub 2 divided by 2. So we get 5 pi fourths. Remember, I'm looking for this point right here. 5 pi fourths plus this pi fourths divided by 2 is equal to 6 pi fourths divided by 2. This is 2 over 1, isn't it? And if you don't mind, I'm going to go ahead and take this and make this 3 halves. So 3 halves. Remember, this comes up as its reciprocal. So I multiply this times 1 over 2. I'm using this denominator right here. And this turns out to be 3 pi fourths. So this is 3 pi fourths comma 0. Alright? And if you want to, we can find, we might as well. We're here find this point right here. We know it's a minimum point. We use the same method exactly. And that is that I'm going to take midpoint theorem, so 5 pi force plus 3 pi force over 2 equals 8 pi force over 2, which is 2 pi, right? This is 2 pi over 2, which is just pi, isn't it? So this is pi negative 3. Hopefully you can follow that arithmetic right there. And if I did the same thing one more time, I would get this value here, which would be, excuse me, which would be pi halves, comma, 3, because it's a maximum, isn't it? Okay, so that's how I would solve that. Hope that was helpful. If you haven't already subscribed, please do, and your comments are always welcome. Thanks.